Alright guys, just wanted to make a video of problem 5 on level 3. So we have 1, 3/4, 5/9, 7 over 16, 9 over 25. And the question is asking us first of all to identify whether it's alternating, recursive, geometric, or none. And then to find an expression, or perhaps better an equation for the nth term. So I've gone through and I've said, well, it's not alternating because there's no negatives, right? Remember, alternating has to go negative, positive, negative, positive, negative, positive. It's not recursive because it's not defined as through another term. Remember, recursive said like an equals an minus 1 squared or something like that. It's not geometric because there's no common ratio. To go from 1 to 3/4, I multiply by 3/4. To go from 3/4 to 5/9, I do not multiply by 3/4. Therefore, no common ratio. And it's not arithmetic because there's no common difference. 1 plus negative 1/4 gets me here. 3/4 plus negative 1/4 does not get me to 5/9. So therefore, it is none of the 4 types of sequences. So because it's none of the 4 types of sequences, we can't use any of those general formulas I gave you today that work for arithmetic and that work for geometric. Therefore, we need to do a little bit of investigative work. So we need to look, if you look at the bottom, right, again, I've just rewritten the sequence here, 1 over 1, 3 over 4, 5 over 9, 7 over 16, 9 over 25, and so on. The bottom are all the squareds. 1 squared, 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. So the bottom is just n squared. So the first term, 1 squared. Second term, 2 squared. Third term, 3 squared, and so on. If you look at the top of the fraction, the numerators are just every odd number. And how can we represent odd numbers? Well, think about it this way. The second term has a numerator of 3. So it's like 2n, right? 2 times 2 is 4, minus 1 is 3. Look at the third term, 5. 2 times 3 is 6, minus 1, 5. Look at the fourth term, 7. 2 times 4 is 8, minus 1, 7. There is no way to know this except by playing around with the numbers and just trying to see what works. Anyhow, now that I've found this works for the numerator, I know the denominator is n squared. I know any term, the nth term is just 2n minus 1 over n squared. Let me zoom out again. So again, I figured out that it was none of the sequence types that we discussed today. I saw that the bottom was just n squared. I saw that the top is just odd numbers, which you can represent as 2n minus 1. I showed you how we got that. And then finally, we know that the nth term must be 2n minus 1, which is what's on the top, over n squared, which is what's on the bottom. Let me zoom out one more time. And with that, I'm signing off. I'll see you guys tomorrow.